Today we're going to be working on sequences. So we're going to be working and finding what the sequence is, how much is it increasing, and then also we're going to be looking at the nth term, which means the unknown term. So your objective today is to describe the relationships in a sequence and extend the terms in an arithmetic sequence or patterns. So that just means like what's happening in the sequence and then just find the three numbers that come next. Here's the vocabulary terms that you need to know. So the first word is sequence. What is a sequence? It's an ordered list of numbers, like 2, 4, 6, 8, right? Term is a number in the sequence. So let's go ahead and I'm gonna write a sequence is like 2, 4, 6, 8, and then it continues, right? A term in the sequence would be 4. Okay. It could be also 2 or 6 or 8. An arithmetic sequence is a list of numbers where each term is found by adding the same number to the previous term. Okay, so in this case, we're adding 2 each time, right? So let's look at this example. How would you describe this sequence? So how much am I increasing each time? Yeah, again, we are increasing 2 each time. Okay? Okay, so now we're going to get into it. So we're going to describe and extend sequences. So terms can be written as whole numbers, fractions, or they can be written as decimals. So let's go ahead and we're going to describe and extend. So remember, it's asking for two things. So we have to describe it and extend the following sequence, and we're extending it by 3. Okay? So let's look at the sequence. So I have 8, 13, 18, 23. So first to describe it is how much is it increasing from each one here. So I'm going to look here. So to get from 8 to 13, I'm adding 5. Well, let's see if that's the same to get from 13 to 18. Is that adding 5? Yes. How about to 18 to 23? Yes, it's adding 5. So to figure out these next ones, I'm going to add 5. So what is 23 plus 5? Well, that is 28. Now I need to, from the 28, I'm going to figure out my next term, which I have to add 5. So what is 28 plus 5? Yes, so it's 33. And then my next term, to figure out my final term, or in this case, just the next 3, right? This is my this third one, is I have to add 5. So 33 plus 5 is 38. Okay? So let's go ahead. So how did we get to the next number? Well, this is describing it. So each term is found by adding 5 to the previous term. So I'm going to go ahead and write that for you. So each term is found by adding 5 to the previous term. A short way to say is that you're adding 5 each time. Okay? So those are two ways to say it. The next question is, what are the next 3 numbers in the sequence? So the next 3 numbers are 28, 33, and 38. Okay, let's go on to the next problem. So here's our next problem. I need to describe and extend each sequence by 3 numbers. So I have 18, 33, 48, 63. So in this case here, how much am I adding? I'm adding 15 each time. So now that we know that we are adding, so describing it, we are adding 15 to the previous term. Okay. the next thing is we have to extend each sequence. So if I start with 63, I'm going to go ahead and put a line here, and we want 3 different ones. So I'm going to add 15. So what is 63 plus 15? Well, this is 78. Okay. The next one, I would have to add 15 to, 15 to the 78. So I have 78 plus 15. That would be 93. And then the last term, let's do a different color, would be, I have to add 15 here. So I have 93 plus 15. So I have 108. So my next 3 terms would be 78, 93, and 108. And that would be my final. So these are the 2 things, so this describing and the extend. So the next 3 terms I just wrote on there was 78, 93, and 108, just to be more clear. Okay, so now we're going to learn how to write an algebraic expression. So each term in a sequence has a specific position. So we're going to call it like maybe position 1, position 2, okay? You can write an algebraic expression to represent the relationship between any term in the sequence and its position. So for example, I have 2, 4, 6, 8, okay? So I'm going to say that this is position 1, position 2, position 3, position 4, okay? So let's go ahead and look at the table and see what's going on here. So here's the table. I have my positions here, 1, 2, 3, 4, and my final answer is 2, 4, 6, 8. So I have my position, and what happens to get to this 2? Well, let's look at this one. This is 1, position 1, and then in order to get the 2, I have to multiply by 2, okay, to get that 2. Let's look at position 2. So if I start at position 2, how do I get to 4? Well, yeah, you can add 2, but that's not what we're doing, actually, if we're considering the position. We multiply by 2, and you get 4. All right, so for position 3, this is where you would really find out here, if I multiply this by, if I add 2, that's not going to get me to 6, right? And I need to get 6. I have to multiply by 2. So 3 times 2 is 6. And then here is 4 times 2, which is 8. And if you think about it, what are you doing? You're repeating addition, and repeated addition, you're adding 2 each time, right? So repeated addition is multiplication. So you're really multiplying each position, right? So that you can think of it that way. So I have this term value. Now the question is, if I make this box here, and I want to figure out any number n, so I'm going to put n for number. So I don't know what position it is, so I'm going to say n, and then it would be, what is it? It's going to be times 2. Well, what is n times 2? Well, that is just 2n. And that's the simplest way to write 2 times n, is with the 2 in front and then your variable. So if n represents the position of a term in the sequence, which is 2n, we figured that out, what's going to be its value, or 2n will be its value. So I want to figure out what will be the value of the 10th term. So I'm going to go ahead and make another box right here, my beautiful little table, right? And I want to figure out 10 without doing all those numbers in between. Well, it's position 10, and I have to multiply it by 2. So what would that give me? Well, that would give me 20, or 2 times n, right? Which is 20, okay? So my 10th term would be 20. And that's the end of sequences. We will be going over it in class, so please make sure that you're taking notes on this. and be prepared for tomorrow. All right, see you guys later. Bye.